Hey guys, Coach Sharf here. Welcome back to my videos. I'm gonna break this up into two parts, but I'm recording it all at once. It's late Sunday night, but finishing up the packet from last week, the one that y'all got in class. So I'm gonna do 17 through 23 on this video, 24 through 30 on the next video. I'm gonna post them when I get done, so they'll already be up Monday morning, and I'll send out a message about that, and then talk about the work this week. And I'm also going to try to get, I haven't decided if I'm going to do one per class period or just one for geometry in general, but do some Zoom meetings this week. All right, so we're starting with 17. As y'all can see, I already kind of drew it out. Again, this was something we did not go over. So I plotted the points. I got -2, -3 right here. So let me put the letter so y'all can see it. R. T was up here at 4, 5. If you sat there and counted it out, S was over here. Okay, so between R and T, you had to go up 8 and over 6 to get there. So again, it's distance formula, but you can also use it to make a right triangle. 6, 8, 10 would, this hypotenuse being 10 would make that right triangle. This distance is 4, going down is 3. So this hypotenuse on this right triangle, so that would be a right angle. That would be a right angle, would be 3, 4, 5. Okay, so I had two distances, 10 and 5. And then from S to R, I went down 5 over 10, which, again, as we see here is a right angle. So I would have gotten this distance was 125. Well, if you look, this is also 10, this is also 5. And then the line that connects it is the square root of 125 as well. So that should be a right triangle as well. So this one should be A. Again, not something we did, and I had to kind of draw it out to double check before I showed it to y'all. So there it is. All right, 18. Molly wishes to make a lawn ornament in the form of a solid sphere. The clay being used to make the sphere weighs 0.075 pounds per cubic inch. So it weighs 75 thousandths of a pound per cubic inch. If a sphere's radius is 4 inches, what is the weight of the sphere to the nearest pound? So we have pounds per cubic inch. So if we multiply it by the number of cubic inches, that will give us our weight. We know it's a sphere. It tells us the radius. So all we got to do is calculate the volume to get the cubic inches. Again, showing, so y'all remember, 4/3 pi r cubed. All right, so not have my hand right in there. So the volume is going to be 4/3 times pi times the radius 4 cubed. And again, I would do 4 times pi times 4 cubed, which really turns into 4 to the 4th power times pi. But you can still write it like that, divided by 3. And that's going to give me, reaching up for my calculator. Let's see here. I don't get the reflection of the lights. All right. 4 times, where's my pi times 4 cubed. Gives me that. 804.25 divided by 3. Gives me 268.08. I will write that on my paper, but I'm going to leave that in my calculator, because then all I have to do is now multiply it. So this is the volume, 268.08 cubic inches. So now all I have to do is multiply it by the 0.075, and that will give me the actual weight. So multiply it by 0.075. I get 20.1, and 20 is one of my answers, B. So there we go. Okay. All right, 19. The ratio of similarity of triangle BOY to triangle GRL, so boy to girl, is 1 to 2. So basically what that's saying is every side length on triangle boy, on triangle girl, it's twice as long, so double that. BO is represented by X plus 3. So BO, that line segment. GR, first two letters. So BO, again, if you want to draw it out, let me draw it out real quick if I can get the paper to hold still. Okay, here's BOY. Draw G. I know it doesn't look twice as big, but y'all are getting the idea. Okay, GRL, BO, GR, are the similar sides is represented by 3x minus 1. But it says for every 1 BO, I have to have 2 of GR. So really, I got to multiply that by 2. So it's going to be x plus 3 equals 2 times, again, trying to write and hold this down with one hand is not easy, 3x minus 1. And put a calculator on, that might help. Get a paperweight. So x plus 3, distribute the 2, gives me 6x minus 2. All right, so let's see here. I'm going to add 2 to both sides. I'm going to subtract x from both sides. This is going to leave me 5x. That's going to cancel, leave me 5. 5 equals 5x. So x is 1. But again, you got to look at what the question's asking. The length of GR. So we don't want x, we want the length of GR. I'm looking at that. That wound up being no. That's right. That's right. Oh, okay. No. I flipped it. Okay, because this is what was gonna happen. So if you plug that in, if you plug this in, what you're gonna get is 1 plus 3 is 4. 3 times 1 is 3. Minus 1 is 2. So you're actually gonna get. You would have gotten this is 4, this is 2, so you would have getting it flipped. You would have gotten this doubled. So I didn't need to multiply that by 2. I needed to multiply this one by 2. Okay. So, see, we make mistakes even as teachers. It's okay. All right. So 2 times x plus 3, because that's what you got. That's actually what you got to do. You got to multiply boy by 2 to make it equal girl. That's what it is. I flipped it. It's all right. We're allowed to make mistakes. All right. Put the paperwork down again. Distribute 2x plus 6 equals 3x minus 1. This is going to look a little better now. All right, so minus 2x on both sides. Add 1 on both sides. That cancels out. Leaves me x. That cancels out. 6 plus 1 is 7. So 1x equals 7, or just x equals 7. All right, so now length of GR is what? Again, x is 7, but we don't want x. We want the length of GR, so we got to plug it in. So I plug in 7 here. 7 plus 3 is 10. If I plug it in here, 3 times 7 is 21 minus 1, which is 20. So GR is now twice as long as this, and GR is 20. So the answer is D. All right. Designer needs to create perfectly circular necklaces. Necklaces need to each have a radius of 10 centimeters. What is the largest number of necklaces that can be made from 1,000 centimeters of wire? So this is where you need to have the understanding that she's making perfectly circular necklace. I'm going to do it up here, all right? It was pretty good till the end right there. Radius is 10 centimeters, okay? So the string needed to make the necklace is going all the way around, which of course is the circumference. We do have circumference on here. There we go. 2 pi r, right? So the circumference is 2 times pi. I'll just go ahead and fill that in as 10, which is 20 times pi. I don't need my calculator for that. That's going to be 62.83 centimeters. Okay. So we need 62. I know the camera's a little shaky. I actually bought a tripod from Walmart trying to get something a little more stable, but it was broken when I took it out of the box. So I might wait to go to, well, they have a limited return policy. I might need to go return tomorrow, but I'm probably not going to get anything else. Anyway, so that's the amount of string needed to make one necklace. So how do we figure out the total number? Divide that by that. So I'll show you 20 times pi just to show it. Light's in the way. There we go. There's 62.83. All right, so do 1,000. Move that down, man. Oh, there we go. Divided by 62.83. 15.9. So you got 15, you got 16. Your inclination is going to be to round up to 16. But again, this is what you got to remember, guys. This isn't rounding. We have exactly 1,000 centimeters of wire. So we can make 15.9. So we'd have 15 perfectly good circles, and then the last one would probably be about like that. It's not going to complete, guys. The necklaces have to have a radius of 10 centimeters, so they have to stay that wide. We can't make it a little smaller, so we can't round up to 16 on that one. So that's what a lot of y'all probably did if you tried this on your own. And I understand that, but you got to kind of understand the context of the problem. So our answer is 15. Don't have enough to make 16. Need a little more. All right, given ABC is congruent to DEF, which statement is not always true? Again, a congruency statement. This triangle is congruent to this one. So again, angle A, if you want to draw it out. Again, I know it doesn't look perfectly congruent, but y'all follow me. A and D match up, B and E match up, C and F match up, right? So everything's the same, all right? So BC is congruent to DF. Well, BC is the bottom side. DF is over here. Now, they might be the two different sides. Again, they don't match up. They're not corresponding. Couldn't think of the word. They're not corresponding sides. They could match up if these were both equilateral triangles, or if they were even an isosceles triangle, where these two sides were your same sides on an isosceles triangle. But it says which statement is not always true, so it's not guaranteed that those two sides are going to be congruent. Okay, measure of angle A equals D. Those match up. Area, if the triangles are exactly, area and perimeter actually, if the triangles are exactly the same, they'll have the same area and the same perimeter. So your answer is A. All right. Under which transformation would triangle A prime, B prime, C prime, the image of triangle ABC, not be congruent to ABC? Again, this is where you have to have an understanding of the transformations. Translation, we just move it, but we don't change it. Rotation, we spin it, but we don't change it. Reflection, we flip it, we don't change it. Dilation, we make it bigger or smaller. So if we make it bigger or smaller, of course, it would not be congruent. It would not be the exact same as the previous one. So, of course, our answer there is D. All right, 23, last one. Diagram below shows two similar triangles. Again, they're going to have different side lengths, but all the angles are going to match up. So the right angles match. Those have one congruency arc, so those match. So this angle and this angle both have to be the same, so those have to be theta. Okay? That has to be theta. If tangent of theta equals 3/7, what is the value of x to the nearest tenth? So we'll say tangent of theta on this triangle. They leave it blank for a reason, okay? If you're labeling it, this is your hypotenuse. This is the opposite side because it's across from theta. This is the adjacent side because it's the one that touches it. Again, if we go back and look at tangent, it's opposite over adjacent. Opposite over adjacent. Opposite is 3, adjacent is 7. So we can say 3 and 7. All right? So now if we're kind of comparing it to this triangle, the 3 and the 2.4 match up, the 7 and the x match up. So we're just going to make a ratio. 3/7 equals 2.4 over x. Next thing is to cross multiply. 3x equals 16.8. Divide by 3. It's going to give me 5.6, which is answer choice B. All right, so there we go for 17 through 23. I'm going to stop recording on this one. Look over 24 through 30, make sure I'm good to go. And then we'll record that as a separate video. Again, I'm trying to avoid having a 30-minute video, so I have 2 smaller videos. And then I'll talk about what else is to come this week, and I'll send a message out tomorrow morning doing so as well. But let me hit stop on this, reload, and do the last 7 problems.